Hope you're doing fine. It's quite hot though, isn't it? I suppose a little bit of an introduction about me. My name is Jakub Trond. I've been a Rust software engineer for like about 4 years now. I started my career in game dev and game dev tooling, then like, technology for the tourism industry, and now I work on blockchain technology. So I suppose, like, in my personal opinion, it's quite a journey. Today's presentation is titled, Can you trigger all Clippy lints and live to tell the tale? And the reason for all the asterisks is because, well, there are 348 Clippy lints in total, which at roughly 50 minutes of presentation time that I've been allotted, comes out to 7 seconds per lint. And I measured 7 seconds is less than a full sentence. So it's completely unfeasible for me to go through all the lints. I will go instead through a subset of them. But before I tell you what subset it is, I'll need to tell you a little bit about Clippy itself. What is it, why is it, and how is it organized? Clippy is the standard Rust programming language linter. Now you might be wondering, what is a linter? I hope that most of you know what a linter is, but if you don't, I don't think there's like a rigorous mathematical definition. A linter is simply a program that analyzes your code and gives you warnings or errors or suggestions that a compiler, or interpreter for that matter, typically cannot or should not. Like, for example, ignore my comment names. For example, the JavaScript ESLint linter might suggest to you, hey, you probably shouldn't be using the double equal operator because in JavaScript it has weird behavior. Please use the triple equality operator or something like that. The ESLint also will tell you your code is in the wrong style, like maybe your curly bracket is in the wrong place, please don't do that. In Rust we would say that is the job of the formatter, but to each their own. And Clippy, as I mentioned, has these 348 roughly lints, because some of them are not unstable, some of them are like a nursery, so it's, yeah. And they're divided into groups. There are 8 groups. They're as follows: correctness, suspicious, style, complexity, perf, pedantic, nursery, and cargo. You can see the descriptions for each of them right here. I think the most important ones are the ones from perf up. So correctness, suspicious, style, complexity, perf. And each group is assigned a warning level by default, right? So lints in the group correctness are assigned the deny level. You might sometimes in your code see or write the attribute deny, allow, or warn something. So the correctness group is the only group that is denied by default. If you trigger a lint from the correctness group, the Clippy will shout at you in scary red letters and tell you that you shouldn't be doing this. Suspicious, style, complexity, and perf are all warned by default. So if you trigger a lint from each of these groups, it will give you a warning in yellow warning letters. The other ones are set to allow by default. These are lints that, you aren't committing anything seriously wrong in your code, but maybe you just want to annoy your coworkers by enabling one of these lints. And I figured, if I only have this limited amount of time and I have to cover the most, I suppose, interesting lints, well, then it will make the most sense in my mind, to cover the lints from the correctness groups, because they are the most egregious, Rust sins that you can commit. Yeah. In my time of going through all the available lints, I further, because it's still like 70 lints total, right? Which gives me 30 seconds per lint. Still not a great calculation. I need to cut down on time per lint further. We need to optimize. And I divided them into 4 further groups, which is trivial, more than trivial, interesting, and pitfalls of unsafe. Trivial are the lints that I just figured out are kind of self-explanatory. They're still like correctness, right? So they're still pretty bad to commit, but they don't require a lot of explanation from me. More than trivial, I will spend a little more time on each of them. The least numerous, I suppose, group is the interesting group, which I just found interesting. There isn't, any objective reason why they're interesting, but I just spent the most time on it, and a sure Excel will force you to spend the most time on them as well. I will actually go through each of these lints and show you how to fix it. And final group is the pitfalls of unsafe, which are quite interesting from my point of view and to me personally. And I leave them here as a sort of safeguard in case I talk too fast and I run out of lints by the end of the presentation. If that happens, we'll go to the pitfalls of unsafe lints. But they're sort of interesting because, unlike the interesting ones, they aren't fixable most of the time, right? They are usually pointing out some code to you that is fundamentally wrong, that you just cannot do most of the time. You probably can achieve something that you were trying to achieve with that code by doing like some architectural changes and pretty big refactor. Before we get started, I want to bask in the glory of triggering all the lints. So let's just run cargo clippy and see how that looks like. Yeah, it's not very impressive on a small screen, but
this looks like a typical cargo clippy.
I know, right? At my work, I have the same. Just goes on and on and on. Okay, that's enough. We're fine. So I'm gonna get myself some water here because my throat is gonna give out at some point. Maybe here so I don't obstruct the camera. And let's go on with the trivial lints. Are you ready? Almost swapped. This lint triggers when you have almost swapped, the two things that you were trying to swap. In this case, we assigned to A the value of B, and then we assigned to A the value of, to B the value of A, which is now the value of B, effectively erasing A. What you need to do to fix this is introduce a temporary variable. Async yields async is a lint. I'm going to expand this here. By the way, is this visible? Should I change the theme to be brighter or whatever? It's fine? Cool. Async yields is async. This will trigger when you have an async block that also, which in itself is a future, which returns from itself something that is also a future. What you end up with is like a double future, right? So you have to await for it to make it correct. I don't actually find this particularly egregious. I suppose this is kind of nasty to see in your code. What you should probably do instead is await on this function call here. Compare nan. Nan, not a number, is magic in the sense that it can never equal to itself or anything else. It can never be compared to anything else. So if you compare a value to nan to see if it is nan, then you will always get false. This method will always return false. You should instead use the isNan method. And I just found it cute that the error message from Clippy here says that the comparison is doomed. Derive hash XOR equality. Some standard library types, such as the hash map, depend on a certain invariant to be upheld, which is that the hash implementation must be congruent with the partial equality implementation, right? It must behave in the same way. If an object has if two objects have different hashes, then they must not be equal to each other. Therefore, Clippy will warn you if you try to derive one of these implementations and implement the other one manually. Derive ORD, XOR, partial ORD is the same sort of situation just for the partial ORD and ORD traits. Drop copy does nothing on types which are copy, this is useless, this doesn't do anything. Drop ref, same thing because every reference, every non-mutable reference is also copy. Equality op, this lint checks for situations in your code where the two operands on each side of the equality operation are exactly the same. Erasing op, this will find for you expressions in your code which like multiply by 0, something by 0, essentially yielding 0 always, right? Same like 0 divided by something. Forget copy, similar to drop copy and drop ref, we have the forget version. If you don't know, the forget method is, the forget function is a function that will drop your value without running the constructor for the given type, the deconstructor for the given type. Forget ref, same situation, dropping a reference does nothing. If name then else, this will trigger where the two branches of your if-else expression are exactly the same. If same condition, this will trigger when the conditions on the if and the else if part of the expression are exactly the same. Invalid regex, this will check at compile time if the string literal that you put in the regex new method is a valid regex. And fun fact, as of 3 days, the example provided on the Clippy website is no longer incorrect because it used to be this, which is actually a correct regex, although I haven't delved into what it tries to accomplish as a regex. It's very weird. Iterator step by 0. Step by 0 does nothing. This is just a very convoluted way to panic. Match string case mismatch, I really like this one. If you call 2 lowercase or 2 uppercase on a string, and then you use its value in a match, and you compare it against literals which are of the wrong case, well, Clippy will tell you and protect you from yourself, which is very nice. Min-max, called in incorrect order, this method always returns 0, because, well, imagine A is 51, maximum value of 51 and 100 is 100, and the minimum value of that and 0 is 0. This would just always return 0. The calls should be swapped. Mismatch target OS. Basically, if you use the config attribute and you put here Linux, this is incorrect. It should be target OS Linux or config Unix. Never loop, loop that never loops because it breaks immediately, is a useless loop. Option unwrap. There exists env macro, just use that instead. Out of bounds indexing. This will check whether or not you're trying to index an array, a slice, that the compiler, or I suppose Clippy, knows the size of, and you're trying to like index out of range, which would panic at compile time, at runtime, but instead it will be caught by Clippy. Panicking unwrap, this will catch for you the unwraps that are guaranteed to panic. So in this situation, max item is none, and then you try to unwrap it, so this will always panic. Recursive format impl, FMT display, the toString trait is implemented for all types that implement FMT display. Therefore, if you call toString from an FMT display, you are recursing infinitely and you will overflow your stack. Self-assignment, don't be like, the self doesn't make any, it's not important here. It's just that you assign something to itself. So this could be like A equals A, and Clippy will catch it for you. Size of in element count. Some methods in the Rust standard library, like this copy non-overlapping, expect a size of the data that you are operating on. But the size of the data is not in bytes, it is instead in the number of items, because like Rust is aware of the layout of the memory. So you shouldn't multiply it by the size of this type. Suspicious split n. Split n is like the split method on a string. It will give you an iterator of these sub slices of the string separated by this character. Split n will give you at most this many as specified in the first argument. Therefore, calling split n with an argument of 0 or 1 will yield you always one value. So it makes no sense to call it at all. Uninit, assumed init. Like, should I say more? This is immediate undefined behavior and probably will break your code. Unit return expecting ord. Okay, this is a. Do you see it maybe? Yeah. Because of the semicolon, this closure actually returns a unit, even though like I'm trying to compare, say, by this second value, this second number here, what I will actually compare is by a unit value, which will always be true, equal to itself. Vec resize to 0, this is a no-op, this does nothing. Resize will only resize like to larger value. While immutable condition, I also like this one. I once triggered it in real code. If there's no way for this condition to ever change, right, because I never changes, Clippy will catch it for you and tell you. Okay, these were all the trivial lints. I'm going to drink a little bit of water. Was it too fast? No. Was it understandable? Yeah. Okay. More than trivial. Absurd extreme comparisons. This is partially here because of the just the totally extra name. But this will catch comparisons which are wrong in the sense that you're comparing, like, say, 100 to the maximum value of I32, which obviously, like, this will never be true. And this will never be true for any value you put here, because it can never be larger than the maximum value of that specific type. And Clippy will, and on Rust, like the compiler itself will also tell you that if you just have the value in plain text, I suppose, but Clippy will also tell you if you're using a constant. Approximate constant, Clippy will warn you if you're trying to hard code into your code a well-known constant, such as the value of pi or the value of tau or e, and it will tell you to just use one of these standard library values. Bad bit mask. This is a little bit similar to a lint that I'll talk about later, which is the ineffective bit mask. This one warns you about bit mask operations which will, like, always be true or never be true because of the second constant. In this example, I hope you can, I hope it's clear. I hope you can see that, whatever value is here in the x, if you bitwise end it with an 0101, well, this can never possibly be larger than 0101. This will always be equal to 0101. Similar situation for the rest of these. Yes. Clone double ref. So this has to do with Rust's out-of-the-referencing rules, out-of-the-referencing mechanism, which is a little bit of like Rust magic that you might not be aware of, or likely you don't think about it because it just feels so natural that it's the way it should be. But from compiler's point of view, this isn't straightforward at all. If you call clone or on a value of x, which is some type vec, the compiler will actually convert this x into a reference to x and then call clone on that. This behavior is suppressed if you're operating on like a single level reference, but, it's suppressed, it's suppressed if you're operating on a single level reference. So this was, if you call clone on ref to x, this will still give you vec. But if you call clone on double reference, it will just give you the clone of the reference itself. Deprecated semver. In the deprecated attribute, you should use in the since field, argument, whatever, a proper semantic versioning string, not some random gibberish. Enum C-like unportable variant. This is triggered when there is a possibility that your specified wrapper view size, which is a platform dependently sized type, so this can be 32 bits or 64 bits, and then you have one of the variants be 100 million, which cannot fit in 32 bits. To fix it, I would just advise you use 64. Ineffective bit masks. So previously we had bit masks which were always correct. This, on the other hand, will warn you if your bit mask doesn't change anything, right? So it doesn't matter if I OR this value with 0110, it will not change the result of this operation with respect to this value on the right-hand side. Yeah. Inherent toString shadow display. If you implement a method called toString on a type, and then you also implement FMT display on a type, then the blanket implementation from the FMT display will implement toString, which you will just shadow with this implementation of toString, which is, I suppose, maybe you have a valid use case for this, but Clippy will warn you anyway. Inline FN without body. If you want to inline a function on a trait implementation, this is fine and very doable, but you have to provide a body for the function. So like you cannot say, all implementers of my trait must have their function inline. Instead, it's up to the implementer of the trait to say, hey, I want to inline this function every call or something like that. Invisible characters. You might be tempted to believe that this entire file is what, 300 something characters. It is actually more than 759. So like this file is more than 1,000 characters because this thing here is filled with 0-width spaces. And Clippy will warn you about characters which are invisible in your code. Iter next loop. Again, I will ask you, do you see what is wrong with this code? Exactly. If you give this function a slice of, say, 1, 2, 3, you might expect it to iterate 1, 2, 3 on each line. Instead, you will just get the 1. Because the iterator here, when called next, returns an option, and an option itself implements into iterator, therefore it will just iterate over the single value in this option. Does this make sense? Cool. Let underscore lock. This has to do with a subtle but important difference between let underscore equals something and let underscore name equals something, right? Let underscore equals something is equivalent to a drop. On the other hand, if I put it here, let underscore lock, this will extend the lifetime of anything that is here until the end of the scope. So it makes sense for to use it with a mutex, I suppose, if you want to lock your operation, but you don't need the value in the mutex. But doing this makes completely no sense at all because it will just lock the mutex and immediately drop the guard. Logic bug. This is like overcomplicated on purpose, but this is a redundant logical expression. Clippy will warn us that in fact what you need is just this. Mistyped literal suffixes. In Rust, your number literals can have any number of underscores in any place except for like the first character. So like this is a totally valid number and it will be valid no matter how many underscores I put there. I have an idea to actually submit a crate at one point which is like 1 gigabyte large, but it's just one number. And you can also postfix your numbers with a specific numeral type, right? So you can say 1U8 or I don't know -2I16. But an underscore can also go there. And if you do something like this, where you maybe forgot to put the U, yielding you a much larger value than you initially wanted, Clippy will warn you, which is very nice. I feel very protected by Clippy. Modulo 1, running an operation like x modulo 1 or x modulo -1 is useless. X modulo 1 will always give you 0. X modulo -1 will also always give you 0 or panic. And it will panic when you modulo a minimum value of the specific numeral type. And in fact, I suppose this was deemed so incorrect that the Rust compiler itself will not allow you to do this, so this example doesn't even compile. Non-octal Unix permissions. I also really like this one. There is a mode method on the open options struct in the FS module, which allows you to set like the Unix 777 or something permissions, but the permissions have to be in octal, not decimal. If you set it something like this, which I think is like all read by everyone, I don't know, this will actually give you 674, which is not what you want. You should instead use 0x for octal values. Yes?
For hex, right? So this would be
0, oh, yes, you're correct. Good point, thank you. 0, oh. Yeah, nonsensical open options. It makes no sense to truncate a file for reading. That's it. Possible missing comma, I also really like this one. It's very useful if you're doing something like this kind of matrix. If you have an expression that looks something like this, so you have a something minus something, but crucially there is no space here, right? Then Clippy will tell you, hey, maybe you're missing a comma here, which I did. Reversed empty ranges. Ranges in Rust, well, range is a type that you can treat however you want if you're implementing your own methods, but in the standard library, like iteration side of things, they don't work in reverse, right? So you cannot go 3 to 0. Instead, you have to go 0 to 3 and then reverse it. Undropped manually drops. If you drop a manually drop, this will not, like, you just said to the compiler, hey, I'm going to manually drop this, and then you don't. So it's a betrayal. Please don't do that. Unit comparison, this is something that we've seen before where a treacherous semicolon will lead to your value being, in fact, a unit, not what you actually want, which is a number, and this comparison will always be true. Similar situation with hashing. Hashing a unit does nothing. So if you actually want to have a hash for an empty value, you should probably use a constant like 0 or something like that. Unsound collection transmute. I didn't put it in the pitfalls of unsafe because I just don't think it's it's too quick to talk about. But basically you cannot transmute collections. Like maybe it would make sense to transmute a vec of U16 to I16. You would get weird values, but this would be correct because, the alignment of the memory is the same and it's the same length and stuff. But this is entirely different. These items of the array will be entirely different, therefore leading to undefined behavior. Unused I/O amount. I used to trigger this all the time. At the time, I didn't even know about Clippy, so I just suffered. But basically, the write method on the write trait is not guaranteed to write all the bytes that you give it. You have to actually inspect the returned value, which is the number of bytes it has written, and do this in the loop. Or, if you're sensible, just use the write all method. Useless attribute. This is a little bit nefarious because this can be like in two forms. Either you have it like this, where it's quite obvious what's happening, or I hope it's quite obvious, or it's like this, and you might think, maybe this attribute here is supposed to work on this import statement here. But I think attributes like this don't actually work on import statements, unless maybe if you have like an unused value. But basically, what's happening here, what you want is a bank here to apply this attribute to the entire file. ZST offset, offsetting or performing arithmetic on a pointer to a zero-sized type is a no-op. It doesn't do anything. And in fact, if I run this code through Compiler Explorer, it just generates an empty function. Okay, cool. That was more than trivial. Or was it? Okay, now we're gonna chill out a little bit because I don't know how am I doing with time.
35 minutes.
Well, it's way more than I expected. Okay, we were a little bit late, so I guess it's fine. Okay. So now I'm going to go through each of these lints and actually try to fix it and talk a little bit more about it. The first one is called FN address comparison. What is wrong here? Well, due to the way LLVM works and the fact that Rust uses LVM, it might decide that these two functions are actually the same. So comparing them to one another for this function pointer might, but is not guaranteed to, return incorrect values, right? In fact, I constructed this little test example just to show you that I'm not lying. And I ran this last time and it worked, so hopefully this works this time. If I run this test in the debug configuration, it returns false, right? The two functions are not equal to one another. But if I run it in the release configuration, it's now magically true. LLVM has decided to merge these functions together. So like using function pointer comparison is pretty much wrong. Another downside of comparing function pointers is that not only are they not guaranteed to like not be merged together, in different compilation units, the same function might have two different pointers, which is why this is just very incorrect code. And to fix it, well, you know, if you're using a function pointer, why not just extract this logic into the function pointer itself? So the way I would go about it is to do something like this. Because in fact, you know, if you want to compare equality of functions, to discriminate between them, then there is no way to do this using function pointers. There's a hack that somebody on the Rust Discord told me that if you want to make sure that these functions will remain across different compilation units, then what you can do is you can say public static other fn of type f equals other fn. And this will be the same across different compilation units, like this value. But this will still not protect you against, like this will still be equal to the public static myfn if LLVM decides to merge them. Okay, so let's fix this. Maybe before I fix this, let me just prove to you that this actually does trigger this lint. FN. Yeah, and as you can see, Clippy tells us that this is wrong. So let's fix it. Sorry, I don't usually work on Macs. And this test is like inconsequential. It's not very important. It's just to showcase what can happen. Okay. If let mutex, do you know what's wrong with this code? Oh, come on, let somebody else answer. The ECS system in this example is like a little bit convoluted because turns out that this lint will not trigger for like a, if your function accepts a reference to a mutex, this will not work for some weird reason. So I had to convolute it a little, but this is a mutex, a standard library mutex. If you call lock on it, why is this incorrect? Because in some particular scenario, this is always guaranteed to deadlock. Okay, go ahead.
Yeah, so this log returns a different struct called like mutex result or something like that. And this mutex result implements deref to its inner value. So in this case, we do if let OK, but actually what we have on the right-hand side is not the ECS system itself or the result of the system, but this mutex. So what compiler does is that it's kind of as if you've done first before the if, as if you wrote let result equals self SES log, and then if let OK equals like this variable you just created. And this means in particular that in this else branch, this temporary variable still exists and the mutex is still locked.
Yes. Yes, and crucially, oh, I think the mic just turned on. Crucially,
It just says a single word.
yeah. Crucially, if you the lock method returns a lock result, but it's not like a typical result. You might be tempted to believe that if I get an OK from this, it's fine to use it, and if I don't get an OK from it, then it's like gone. There's no locked thing, right? But that is not true. Lock result is actually a result of guard in the OK variant, and then poison error with guard in it on the error variant, which means, oh no, I cannot oh no, I forgot how to go back in on this Mac. Which means that if I poison this lock beforehand, then even though there is no lock being held on this mutex, this will deadlock on every call. And to fix it, you might want to use the mutex lock. And then because, as I said, like poisoning mutex is a whole thing. It happens when you panic when holding the lock. Not very important. Point is, if you don't care about your lock being poisoned, you can still use it even if you get an error from this method. So you can just unwrap or else and use this error into inner, which will give you a proper mutex lock. Okay. Yeah. Is that clear? Any questions to this? Cool.
It's not matter that the lock method returns OK or this poison error. The mutex is locked. Right?
Yes, exactly.
It's, poisoned, then it's locked. Then.
Exactly, yes. It's still locked. It's still, like, you might decide as a programmer that to do something, like if it's poisoned, then maybe it's invalid and then you release the lock, but it's up to you. But like the method gives you the method just gives you the value regardless. Yeah. All right. Infinite iter. Clippy will check for you if you call repeat one. And I think that's it, because like if you just do something like 0 to infinity, this isn't actually infinity. Obviously, this is bound by the numerical type size, but repeat something will actually be infinite. And Clippy will warn you if you are trying to consume an infinite iterator, crucially, in a way that will never finish iterating, right? So if I try to count an infinite number of values, this will never stop. If I try to sum infinite number of ones, this will never stop. If I try to zip 3 values with infinite values, this will stop, and this will give me 3, because like zip is, it will give you at most that many elements as the smallest iterator in the zip chain. And Clippy is smart enough, and the code for this lint is actually quite sophisticated. It can figure out that this will actually not loop forever, but it knows that if you call chain on a repeat, it will still in fact loop forever. It does not work for variables though, so if you do this, this will not trigger the lint, which is quite upsetting, but oh well. I'm not gonna fix this code because I don't think there's anything to fix. It's just like fundamentally incorrect. Okay. Invalid null pointer usage. You might be tempted to think that if you're trying to like create a slice of length 0 from a null pointer, that this will be correct, right? Surely it must be. Well, it's not. It's actually undefined behavior. Because pointers in Rust, apart from describing you the address of something they point to, they also have alignment, which has to be correct. You cannot read from a null pointer even if you will not actually read anything, right? So in order to use this correctly, we have to use something called non-null dangling, and then as pointer. As pointer. Actually, hold on. I did it in the incorrect order. First, cargo Clippy. Right? And it actually tells us to use just that, right? Use non-null as dangling as pointer. Okay, that's it. SERDI API misuse. I spend so much time on this, it's ridiculous. You know SERDI, right? The serialization, deserialization library for Rust. It allows you to really quickly, really efficiently, effectively describe your data schema, and then the procedural macro will generate all the parsing code for you. That's not strictly speaking correct, but yeah. There is a particular thing about it that it cannot enforce with trait bounds or at compile time, which is that if you implement the visit string method on a visitor, then you must implement the visit as str method on this visitor as well. The reason being is that SERDI thinks of strings in two ways. It thinks of them in serialization when there is only one string. It's just a borrow of a string. But in deserialization, there can exist three types of strings. The borrowed string that transfers through the deserialization, right? So I am, say, deserializing from some string of lifetime A, and my deserialized struct will also have lifetime A on one of its fields that is borrowed through the deserialization. There is what SERDI refers to as transient string. So it will still, from the point of visitor, this will actually be the visit str method. This will be a borrowed string, but you cannot take this string. You cannot extend its lifetime. And there is also visit string, capital letter string, because some deserializers might be able to give you an owned value to a string, therefore allowing you to skip this one clone, right? Very efficient, very nice. But the problem is that this isn't guaranteed to be the case, right? Even if I implement my deserialize method for this data, which is just a string, right? Even if I implement it like this, where I say, hey, deserializer, please give me an owned string, it's up to the deserializer implementation to call visit str or visit string. And in fact, this example, I wrote these two tests that one of them will fail, the other one will succeed, where I'm using different deserialization methods. Here I am deserializing from string, from a string literal, or I suppose a borrowed string slice. And this will fail, right? Because I didn't implement this visit str method. I expect it to be called visit string, but it will call this visit str, which by default errors out. And if I deserialize from an owned value, well, the deserializer can give me the string without the copy, therefore this example will pass. The fix for this lint is very simple, or I suppose let me prove to you that it actually triggers this lint. Right? It tells us exactly what I hopefully told you that you should not implement visit string without also implementing visit str.
Question. Is it somehow connected to the SERDA itself, or is it like...
Yeah, Clippy...
So Clippy must know that SERDA do something,
yeah, so that's what I told at the beginning, that there are some errors that the compiler should not and cannot know about, right? Which is existence of third-party libraries. And you might recall that one of the previous lint went with a regular expression, which also is not part of the standard library. So yeah, it's very nice that Clippy actually knows of these de facto standard libraries which everybody is actually using, and it can tell you and it can warn you when you're committing some sin with regards to this library. Okay, so let's fix this with a visit str. Why isn't it showing up? Sorry. Thank you. This was way too difficult. Okay. This now works, and this is now correct. Finally, the final in the interesting lens is the v-table address comparison. So the weird thing, wait, is that correct? I feel like I missed one. The weird thing about it is that I haven't been able to create an example that will showcase this incorrect behavior. But the lint tells us that, you know, if you are doing RC pointer equal on two RC values, right? You might typically use this if you want to check the two values contained in an RC, like maybe they're equal by value, but you actually want to ensure that they're exactly the same pointer, they're exactly the same address in memory. But if you're using dynamic dispatch, well, this will actually compare the v-table address, which is not guaranteed to be unique per different instances of the same type. Yeah, but I haven't been able to reproduce this, and I don't think there's really... there is a way to fix this by extracting, like converting this to a pointer to U8, to data, and then comparing these pointers, but I'm not going to do this because I forgot to practice that. Okay. How am I doing with time? Yeah, I'm pretty much out of time. Questions?
So this test that we see, it's not failing.
Yes, it's not failing.
But it should.
Yeah, from the point of view of the lint, maybe it fails, maybe it doesn't. I guess we'll never know, you know. Yeah, same. And you know, it's not unsafe. So like, very not very rusty. Okay, I'm out of time. Thank you for the. Maybe I don't want to. Okay, let's go quickly through the pitfalls of unsafe. I haven't really practiced them that well, but hopefully I'm coherent still. But my throat a little hurts. Hurts a little. English language. Cast ref to mute. It is fundamentally incorrect to cast a immutable reference to immutable reference because you are violating one of the fundamental safety guarantees of Rust. You cannot do this ever. If you really need to be able to mutate something through a shared reference, well, you can use a mutex, you can use a cell, a ref cell, or if you're like really into the weird stuff, you can use unsafe cell, which allows you to implement your own internal mutability primitives. Cast slice to different size. This is similar to what we saw before with a transmute of a vector. You might think that when I cast this slice of bytes to a slice of 4-byte numbers, that let's say I give this function 8 bytes, right? You might expect to see two numbers out of it, but that is not true because, as I said before, pointers in Rust have alignment. They expect your data to have a certain length, and the references have like size also. So this will actually yield you, for 8 bytes, an incorrect slice of like phantom 8 4-byte numbers. So don't do this. Mem replace with an init. You might think this is safe because you're like immediately you have this vector which is mutable, right? You replace its values with an zeroed out memory, and then you like do something with it, and then you replace it again, and you drop the uninitialized values, whatever. You might be tempted to do this because, I don't know, efficiency or something. Problem is, whatever happens here, if it panics, for example, this can observe the contents of this the contents of this now uninitialized vector like totally invalid, right? Whatever is there is just magic at this point and chaos. Don't peer into the void, etc. And this will cause immediate undefined behavior. Mute from ref, this is a fun one. If you have a method that the signature of which has like a reference to a mutable reference and it contains unsafe code, Clippy will warn you. But if it doesn't contain unsafe code, Clippy will not warn you, because maybe there is a way to do this using these like unsafe cells and stuff. Not unsafe, pointer, arc, the referencing. You might think like, oh yeah, I put in unsafe because I'm such a good Rust programmer and I ensure like this code is correct. No, this entire function should be unsafe because you're dereferencing a pointer inside it and there is no guarantee about this pointer from outside. If you really want this function not to be unsafe, then this should be a slice or a reference to array. Transmuting a null. I forgot why it's incorrect. Let's skip that. Sorry.
Zero is not a pointer. This is just a number, and numbers are not pointers even though internally they might be represented.
Right, you might think that, but there's another lint that kind of broke my mind, and I asked somebody on Discord about this, and they said, yeah, it's weird, basically. But basically, Clippy will warn you, and the description of this lint, with wrong transmute, is that it warns you about transmute to pointers that are guaranteed to never be correct on any architecture. Problem is, like if I put in here a char, which is 32 bytes, on a 64-bit machine, this will not even compile. So what's the point of the lint? If I put, on the other hand, here a U64, this will not warn me. Because maybe, like, in my mind, my explanation is that maybe, feasibly, somebody might convert a pointer to U64 first and then back. I don't think that's correct, but whatever. But if I put an F64 here, that is always incorrect, because how on earth would a floating point value ever be a correct pointer, right? Yeah, which is why I said, why is this a correctness lint, right? But this here, if I put a U64, not. And finally, uninit vec. So setlen will like allocate your vector up to, it will, with capacity, will allocate your vector with this many number of slots, and then setlen will fill your vector with uninitialized values, but this is obviously very incorrect. If you want it to be correct, the contents of this vector should be something like vec, maybe uninit, string. Okay, that's all. Thank you. Yeah, no questions, right?
Would really vec of uninit be alright? Because you still have vector of uninitialized backed by uninitialized memory. So if you then use setlen, what's the guarantee? I mean, will it automatically fill out the spaces with default values? Because I think what setlen does is that it pretends 1,000 push is
Yeah. Yeah.
But then still you have this uninitialized memory in the background.
Yes, but like that's the guarantee about maybe uninit, is that if I do something like this, that's what I meant, like, this can be uninitialized, right?
Right, because then you have to assume it.
Yeah,
say,
yeah,
okay.
yeah.
Right.
All right, cool. Thank you for your attention.
Możesz zostawić komputer?
No mogę.
Super.
Stronka woli, czy... Okej.
Okay, so thank you for the first talk. Right now, Bartek will do some sort of a lightning talk targeted to beginners or people that want to learn why Rust is interesting and valuable to use. So here he is.
Let me quickly find my talk. Okay. How to full screen that?
Command Shift F.
Okay. Okay, so hi everyone. I'm Bartek from Wrocław, and today I would like to give you a briefly introduction why to use Rust in your project, why to migrate to Rust in your project, and maybe a little why not to do so sometimes. So this is just very, very quick lightning talk. Do not expect any details, but I just want to give you my very subjective opinion about that. I tend to tell about this often, so this is this year edition, and it may change through time. So in a year, this may be a bit different. This may be a bit different. So there are three things which are like keywords in Rust-Lang web page, and performance is one of them. So you want to use Rust when you need your system to be performant, to be fast, and basically you need two things in such cases. You need native binaries as your output, and you don't want to have a garbage collector. I don't say that garbage collector is always a bad thing, but in some embedded systems, in very performance systems, you want not having it. And I am aware about, I think, 4 mainstream languages which give you those traits, and Rust is one of them. C and C++, which are kind of similar. I know that's not the same thing, and I don't want to go into this discussion. It's the other thing. There's Zik, which is getting more popular recently, and there's NIM, which I know one project in. But I think that those 4 languages are your top choices.
As of a few days, there is also Carvel.
Okay, but I'm not aware about that one. But there are not many choices if you really need high performance system. What I really think is important are zero cost abstractions, and I will talk about this a bit more later, especially comparing to C++. And I would only compare Rust to C++ at least on the performance layer, because if you are thinking about migrating to Rust, we do not think about migrating to Rust from Zik. Or maybe we think about that, but those are minor cases. In most cases, we are thinking to migrate our C or C++ projects. And the difference is that Rust, as a very modern language, is designed with zero abstraction in mind. And it very differs from how C++ standard library is designed. I will give an example in a second. And it makes actually Rust code faster than C++ code often. Not because you cannot write as fast C++ code, because you really can do that with assembly in lines, of course. But it makes easier to write fast code in Rust. It's more idiomatic, I would say. Constant by default. In Rust, everything is constant by default, and this fact falls into 2 categories. Performance is one of them, but it also makes your code easier to maintain in many cases. But in particular, this important in performance, from performance point of view, because it makes your code easier to optimize by compiler. When I was working in C++, I don't know, 10 years ago, maybe 7 years ago, there was this pattern to create lambda function, more 7 years ago, lambda function, where you build your string and then return the string and immediately invoke it. So immediately invoke function calls in C++. This was to avoid you having your string being mutable through the whole function. In Rust, you just mutate your string and then you assign it to the new constant value, which is also including another trait of Rust, which is really free moves. In C++ we have move semantics, but it's very different from semantical move in Rust. So move by default, it's literally free. It's always at most the mem copy in Rust. In C++, your move, you can do anything, basically. You can launch your entire system in move constructor. and it causes problems, let's try move your vector or resize your vector. It may be very costly if your values implements move constructor, and it's not sure. Okay, I promised you an example about zero-cost abstractions, C++ versus Rust. And sorry for that, but I am using the old C++, but I don't think that many corporations or many projects are using the new C++ 21, but I will have a C++ 21 example in a second. So what do you do if you want to do some operations on data in C++? First, we create data. I mean, we can have it from somewhere. And then I want to filter my, my values. I don't even consider how much, how bad it looks, because I mean, this is very subjective. Maybe if you are writing C++, you can read it quickly. But the problem is that it is not lazy. You just need to move your items to the end of your vector, and I think it may shuffle your elements at the end. And then you need to erase them. And all of this is happening right at this point of code. It's not lazy, yeah? And then you need to, if you need to map those elements, you need to do another vector, you need to copy those elements to new vector. You can improve this by reserve your elements. I mean, it can be done a bit better. But this is how you transform your data sets in C++. Yeah. I mean, it is not very modern way, I would say. How do you do that in Rust? So you need your input. Okay, you have it from somewhere else probably, so it doesn't matter too much, but then you filter this, and you can read it, but what's more important, it doesn't happen yet. You just define transformation on your data. Then you map those data, and then everything happens. And you do not need any extra allocations. You do not need any extra swapping elements around and anything like that. I know that most of you probably knows that, but why I'm showing that? I'm showing that to show you that even though C++ is considered very fast language, I mean, Rust is faster not because it has better optimizer or something like this. I mean, it has very good optimizer because it can, you know, exploit the fact that everything is constant by default, for example. But what's very important is how it's designed. And also its trait system is designed in the way that it works both for dynamic and static dispatch, and it may help to optimize any monomorphizations, for example. I promised you the example in C++ 21, so yeah, you can define your transformation actually, so you can have your filter, you can have your transform. Maybe someone out of you can help me how to actually put those values into the vector easier than that. I was looking for that.
You have to do it by hand and put the vector of constant values.
I mean, so even now, it's C++ 21 example. You have
fact, sorry to interrupt, it's 20.
Sorry, 20. Sorry for that. But even now, in modern C++, you have no notion of collecting your transformations. Yeah, and this is a performance issue because you don't want to allocate like that. Okay, another thing about Rust is it's reliable. So what does it mean? It means you will not have any exploitable bugs. I know that there is misunderstanding what Rust prevents, and it doesn't prevent like every memory issue. It doesn't prevent memory leaks. It prevents you from doing exploitable things. Why exploitable things are important? Because they cost the most. If someone can exploit your application to get access to system admin, it's bad. I mean, you'll pay for that. And because Rust prevents you from doing those bugs, it's cheaper to maintain software without those kinds of bugs. Also, structured behavior separation. I mean, this is the second language I know. First is Haskell, but Haskell is not very comparable to Rust, where structures and behaviors are really like split between them. You have instead of having interfaces which are actually connected to your classes, you have your structures and you have your traits. And you connect them, but they are kind of separated. They're living in different spaces. We have generics, which are understanding traits. In most languages, if they have some notion of static dispatch or generics, it is very different syntax to use generics and dynamic dispatch. For example, interfaces. The fact that in Rust, you can have your traits and choose if you statically dispatch on them or dynamically dispatch on them makes it easier to maintain your code, because when you are creating your library, you just create your traits and you let your user choose how he would use the trait. You do not need to provide separate interfaces for generic type code and another interfaces for your, OOP style code. Explicit error handling, it's from my experience, but it's very subjective thing. It's way easier to read control flow when you can understand what can fail. Actually, there is this syntax in C++ to tell what exceptions you can expect function to throw, but no one uses it. Yeah, so there is this thing in Java, but in Java you can just throw your runtime error and it doesn't work. It's not the problem that exceptions are bad, but the problem that you cannot even control what can be thrown from the function. You don't have any information in your function signature about what can be thrown. That's a problem, because it's very difficult to analyze this kind of code. In Rust, the error flow is very explicit. You know what can be returned from your function, and even if you can, just do the question mark to forward an error, it's not a problem that you hide the forwarded error, because you can see that error can happen, and what error can happen, and Rust would warn you if you ignore error which can happen. That's another thing. And productivity. This is, sometimes I hear that people say that Rust is not productive because it has steeper learning curve than JavaScript. But if you want to use JavaScript, you don't want to use Rust. If you want to use JavaScript, you don't care about productivity. You don't care about performance, sorry. You probably don't care about productivity too, by the way, because, number of what the facts per minute may kill you, but, jokes aside, comparing Python or JavaScript to Rust makes not too much sense. Compare Rust to C++ or maybe Zeek, or maybe even Go. When you need your asynchronous applications, your microservices, you may compare Rust to Go. But, and if you compare to those languages, it turns out that we have really one of the best tool sets out of those guys. We have dependency management in Cargo. We have easy cross compilations. Another word about that in a second. Type system productivity, very subjective thing, but I really think that having a static type system in bigger projects helps. And great community learning. So toolset, Rust app and Cargo. We install Rust app, and we do not care about anything. We can install any tool with Cargo. We can build. We can do stuff. We have Creepy. We have a whole talk about Creepy. How much more input we can have about how to improve your code. I think there is good tool in Python for that, but most languages doesn't have it. Doc comments. Okay, I know that there is Doxygen, but who is using Doxygen? In Rust, there's this fact that I don't even need to use my docs comment. I just do cargo doc, and I have really good page with all those connections between my entities. And I can just add simple doc comments to improve them. I can even embed tests there. Yeah? And Rust Analyzer, which is working with any environment I know. I am using it with NeoVim. It works with code blocks, not code blocks, with Visual Studio Code. I'm pretty sure it would be integratable with code blocks, but who is using that anyway? Cross-compilation. So you can use your Rust to do embed programming. We had 2 talks last month about this. Most people I know who started using Rust for embedded don't want to switch back to CD. Browser-side execution with WASM. We can create plugins for I mean, parts of our pages in Rust. There's an entire book about that. We can do smart contracts in Rust, and I mean, I promise you will not go into blockchain today too much, but yes, there are two frameworks where you can write your smart contracts in WASM. I mean, probably more than two which are like big ones. Smart contracts, if someone is not into crypto, is a way to program in blockchains, basically. Plugins with WASM. I mean, it's not very popular yet, but there is, for example, this game Scripts, where you can program your AI, which is fighting with other AIs. And you can either program it in JavaScript, or you can upload your code in WASM. Basically, anything which uses WASM as runtime for its plugin, which I think may get more popular in future, would support Rust as its scripting language. Okay.
Sorry, can I have a question?
Yeah, sure.
On the previous embedded programming, what is supported officially in Rust?
Okay, so here is Michał, and he is better one to answer this question, being honest, because I am not doing embedded.
Yeah, I can step in. Yeah, so for sure, vast majority of ARM microcontrollers and application.
Officially, like, supported?
Yes, it is. Yes. You know, in Rust you have the
4 years.
the tiers of support. So ARM is the highest tier, so it is guaranteed to be always working. AVR, Patrick is an expert on this. Yeah, so the AVR is like, it will work. You can validate the binary on yourself. I mean, if you're writing something for a, for a space station or something like this, you most likely have your framework of verification things. So, yeah, basically if... Yeah, it is a big story. By the way, Ferrous Systems, which is a Berlin-based company, I guess, is working towards safety critical systems in Rust. So you will have a Rust edition, or let's say a toolchain that is certified, and yeah, and you can look there if you are into this more safety critical or mission critical things. But anyway, yeah, ARM is for sure supported very well. Yeah, the tier 1. The RISC-V is either tier 1 or tier 2. Hopefully it will get more popular than ARM at some point, by the way. And I think Extensa, which is also interesting regarding the ESP32, for example, is also supported, but it is, I think, tier 3 or something like this. But yeah, the support is quite huge. I mean, even if this is not guaranteed by the maintainers of the Rust compiler or something like this, there is still a huge community that supports it by themselves, and yeah, most likely you are fine to if you are running a hobby project to do it in Rust.
Yeah, also one fun fact. Last year I was playing around cross compilation to Spirf, a platform which is shadow target by NVIDIA, I think. So you can actually write native shadows in Rust, and it mostly works. I think it's share free, so it's not very much supported. But last year it was working with some minor glitches. You needed to avoid send train constructs because they were crashing. But basically you can write even shadows in Rust, and there is a whole working group to work on that. Okay. And learning resources. I told you there is awesome communities, and there is this thing in Rust which I never seen anywhere else. Everything has its book. And what is book? Book is basically a tutorial. But there is a single style how those tutorials are created, and they are very high quality. So we can start with the Rust language, which is the standard book to learn Rust. I mean, very good stuff there. Rust by example, another resource to learn basics of Rust, but in more like practical way. We have embedded Rust book. Whole book, I mean, it's pretty long one, about how to do embedded. Rust and Web Assembly, another book. Cosmos book, which is a bit of self-advertisement because I am an author, and this is about creating smart contracts in Cosmos, and more books. There is another book about Rocket, which is web framework, about Amethyst, game engine. I mean, not everything, but if there is big project in Rust, there is big chance there is a book about that. And by book, I mean like really step-by-step tutorial. And yeah, this is everything I wanted to tell you. Sorry. I am a bit too fast. And if there are any questions, yeah, I promise you to tell you why not to use Rust also a bit. I mean, you really don't want to use Rust for your proof of concepts if you can do it in another language. Okay, if I would create some very quick proof of concept, I would choose Rust because this is the stack I know the best. But it is not worth to learn Rust because you want to create some proof of concept. Also, you need to always consider the fact that there are not too many Rust developers. So if you would need help with your project, you need to consider if you are able to find developers for that. But besides that, I think that using Rust, whenever you need high performance, is probably the best choice. Maybe you can think about Zik, which gives you better memory management sometimes, but in general, I really recommend using this stack in most cases if you are working on your own or you know you can afford developers for that. Yeah, that's everything I have for you, and we have pizza today.
Yeah, okay, so enjoy a break. It will take like, I don't know, maybe 15 minutes, something like this. And after this, we will have the second full-length talk, right? And for those of you on the live stream, brew yourself a tea or a coffee or grab a beer, whatever you prefer, and we will see you in 15 minutes or something like this. Okay, so I guess this is time to get back to listen to a second presenter. So, let me welcome Maciej. I guess he will self-introduce himself. But if I can get you back to the to this room, so we can continue, it would be great.
Zaczynamy?
Przepraszam, czy możemy poszerzyć ekran?
Z rzutnika. Zapytamy, tak. Możesz zwiększyć, no?
Jasne, zaraz zwiększę. Yeah. So hello, my name is Maciek, and like I started playing with Rust like 4 years ago, and then started taking it for each personal project and studies project. But I'm also the fan of programming technologies and programming languages by themselves. So in my free time, I often experiment with new technologies, so I can abandon more projects than usual. And okay, currently I'm employed in a new space company. So we make some satellites and we use Rust on our backends and Python, like on orbit, together with C++. So for today we are gonna talk about the GraphQL, which is like a new technology for creating backend APIs. Like it's often referred to as the successor of REST. Do you know REST APIs? I guess most of you know. And how many of you knows about the GraphQL? Okay, so like the half, let's say. So GraphQL is a sorry, my window manager doesn't support the full screen layout, so it won't be there. But it's written in Rust, so at least that. Okay, so Rust, GraphQL is the query language and also all the machinery for executing those queries in your backend. Compared to the rest, it supports, it uses only one endpoint for all the queries and only the post request. Okay, we will, through this talk, we will first see what GraphQL is on the final example, which we will then create from the scratch. And also we will start with saying why was GraphQL even invented. So let's say we have this data model in our service. It's not really a service. It doesn't have any business case, but I just choose this to present some features. So we have the users tract with some ID, some data, and also the reference to the car ID. Well, actually, this shouldn't be optional, but it's left over. We have some brand of car enum. Not much brands there, but just an example. And also the cars tract, which has also the ID, some data, and reference to the owner. So it's like, it tries to mimic that we have some relational database under the hood, but we don't, to keep the things simple. And there are two main problems with REST APIs, namely the overfetching, where we query backend for some resources, but we don't need all of them. So like, let's say we have some front end and we want to display this kind of the list. So we query for all the users. And we end up with having some data transmitted to us, but those won't be used. So we are spending more time on wire, and we have to process more data than we possibly should. So this is overfetching. Like, this is kind of naive example, but you can imagine like in some real-time services there are loads of data and you maybe don't even need a half of them. And also the underfetching, where we want to present now this list, like users, like the username, and then the car that the user drives. And we query the users, we get the list of the users, and then we have for each user, query the car it possesses, so we can get the rest of information. And this is known as N+1 problem, when we have one query to get some data, and then N queries for each element from the list. And in GraphQL, you can easily just declare the exact structure that you want to fetch. So here we define that we have query from the users object, and we only take the name, surname, and age. And we have only the data that we need for our use case. And so with the referencing, so there is like convention in GraphQL that every type that has reference to some other data inside it, it just is automatically the reference to the object itself. So you can select users and select their car and some data from the car in one query. Okay, it's how could you do that with REST? Like, there is no easy answer. You could define users with cars, or just users and cars true. You could try to define some selector to specify the exact fields which you would want, but it gets complicated when you have the references. So imagine that it isn't just one-to-one reference, but one-to-many, and then inside the references we have again references. It would be just impossible to write, maintain, and develop further. Okay, so this is why GraphQL was invented. We'll also see some crates from Rust ecosystem. So this one is underlined because we are gonna to use this one for our example. So it's async GraphQL. It's backend crate for defining the GraphQL APIs. We also have Juniper there, but I guess it's still not asynchronous. It was definitely when async GraphQL was created. And both of those integrates with all the most popular Rust backends. So like you have ActixWeb, Exom, Rocket, Warp, probably more. And we have two most known client-side crates, like GraphQL client, which requires you to first write your schema, save it in a file, and then it will generate you the code for this. And also the Cynic, I don't know how to pronounce that. It has like the different approach where you define the data you want to query, and then everything is generated. And that's it for the presentation. We'll jump straight to the code. I will like make this a bit bigger. Okay, maybe a bit smaller. Is it okay? Okay, so we will first explore what we have there. This is like the full version, final version of this small example which I wrote. So it's to present you how you can use GraphQL as a client, because GraphQL comes with this like graphical view. It's called GraphQL, where you can like test what you wrote, test your endpoints, and explore. And you just get it for free. It's definitely not a production endpoint, but for development, it really eases up the things. And GraphQL is a strongly typed query language. So we write our API by defining our schema. The schema is basically all the types exposed by our API and basically all the types. So the main root GraphQL type is query. And each type has fields, like here we have users fields and cars fields. Those are fields, but they look like a method because you can add parameters to them. And so we have the type query, which has this users field, and this field returns us users struct, which is not null, because we are in the world of JavaScript, so everything can be null. So we can now specify that this cannot. And this is the list of users, and the list itself also cannot be null. And we have the limit. Oh, I can look there, sorry. Also, we have the limit parameter of type int, and it also cannot be null, and it defaults to the 15. So we can write just query users. And it says us that we tried to query some complex type, which is user. It's not scalar. So we have to explicitly select all the fields that we want to query from it, like the ID and name. Sorry, it's... So my great example just panicked somewhere. It's min, not max.
By the way, what ID do you use?
It's Lunar Vim.
Okay, nice. Not VS Code.
Not VS Code. Okay, and the reason for having to every time we have to exactly tell what fields we want is to make our API less prone to the compatibility changes. Like if, let's say, we didn't have to specify the fields and we queried users, then we would, let's say, get those structures. But in the future, we can add more fields to our user type, and the fact that we had to explicitly specify the fields that we are querying achieves that we don't break anything with this, because users weren't selecting the new fields, and they will also get the same return. Okay, so the query is the root type. There are also two root types, which just aren't required, and those are the mutation and the subscription. In mutation, we will have some function to call for help that simulates that some user requires like our service attention. And in subscription, we will have subscribe for help calls, where every time every time this one is called, then this one will return as some data. It works on a WebSocket. And so, the data model is almost like the one from slide, beside that the user always has car. I had optional there. And also we have documentation, we have like this docs, which is not visible, and that's because I forgot that I would raise the font size a bit here. I hope it makes things more readable. It didn't. Okay, so we will skip the docs page for now. We just, yeah. No one makes mistakes, yes? So we could like also query the info about cars and let's say brand and model. And we end up with exactly what we wanted. And our car also have the reference to the owner, like owner. And this is the user who possesses the car. So it will be ID and name should be equal to those from the user. And here we created a graph of data. This is kind of naive example, but it's really useful in some cases. Okay, any questions about this? I cannot.
How you created basic data source for GraphQL?
We will write all of this example, I hope all of, we will see how much time we will have in a moment, so then you will see how the API is created. I also tell you that you can assign names to those queries, like let's say foo, something got deleted. Let me fix that. Okay, we can assign the name for those queries. We can also define that this query has some variable like the limit, which will be int. And then we can use this here, like limit is equals to limit.
The filter was fields that were specifically specified in the schema, right? You cannot
Yes.
name if you don't have parameter called name.
Yes, that's correct. And then we can pass this variable to each query, like let's say limit is equal to 2. I will show you that there is more than 2. And now if we execute that, we end up with 2 users, and we can save this query. Like in your client, you can probably build it, compile it, or whatever, and then use just like a function with this variable. Okay, I guess we will see some more things during coding this. So that's just the small presentation of the final product.
Also, just out of curiosity, one question, because this limit users is not nullable. So if you now were to remove this exclamation mark on the first line,
Yeah, GraphQL will.
check.
I thought that GraphQL,
Exclamation mark means
it's not null.
okay.
Okay, I thought that GraphQL will tell us that this cannot be null, but
I think it can be because previously you queried it without the limit. So it has.
it has default, like I showed you in the schema.
Yeah.
It has the default value of 15, but that doesn't mean that if you pass this parameter, it can be null, because it can't. Like you see in error, like expected int, it didn't say what it got, unfortunately. Okay, so let's go back to the code. Oh, the letters are quite big. But okay, we will take care of that. So let's kill that. Sorry. Okay. So this is the code that we'll start with. Like we have the type alias for our schema, which is, as for now, the schema with the query, and empty mutation and empty subscriptions, because those two are optionals. And we have some function which builds for us the schema. This is what our backend service will use, like to keep this simple. And we have the struct query with some foo resolver. This will appear. Let's start compiling it. So we will see the docs in a moment. And we have only the types from the presentation, and like the user, the brand, and the car. As for the backend code, like in the main, we have some imports which are uninteresting. We have the GraphQL handler, which handles the post requests to our backend with the queries. We have this playground. And we have the Axum application, like we just defined that we root /GraphQL. When we get it, we get the playground. When we post, we actually execute a query. And also we have some WebSocket for subscriptions. And the schema as the extension. This is kind of the global data that our backend can use in each of the handlers, routes, in routes, and we just bind this to the port 3000 in localhost and run. And I also created some dummy data for this. Like I said, we won't be using any database under the hood, so we have some data to operate on, and this just returns the vector of users, and this one just returns the vectors of cars. And also we have type aliases for both of those, so we keep the code kind of simpler. Okay, so we will only, what happened? Okay, I undid the starting point. Okay, so as for now we are using the star import from async GraphQL. It's not so clean, but from what I saw, it's kind of the design that this looks like a prelude from their side. We could specify everything manually, but not now. Okay, so the first thing we see is that our fields are actually an async functions, not the fields on our data. And this is true for each object that we will make. So without this macro, the code will stop compiling because query doesn't implement object of GraphQL. And this procedural macro just goes through all the async functions that we've defined there and resolves them as the field on our type. Let's delete this because this is no longer valid. We can query for foo, I believe. And it returns us 1, and we have the only one type query which have the resolver of foo to the int which is scalar, so there are no subfields. Okay, this is what we start with, so let's write our users query. Like, let's name this users. Let's make it return users. We will use result. This is not the std result, this is result from async GraphQL, which basically is a result which automatically derives from error for every type that implements toString. So it makes things a bit easier. And this will be like the slice of users. So we get the list. And then we somehow have to get our users there. So we can also attach global data to our schema just by calling data and call our functions which provide the vector of data. And this is any map under the hood. So we can now get our users, like let users equals to, and I forgot one thing. We also need to specify the context if we want to access that global data. So this will be GraphQL context of anonymous lifetime, and we then call context data and the type of data that we want to get. And this may return as data if we've attached this, like here, or may not. So this returns the result. So we can quickly escape with error if something goes wrong. And then we can just return this, I guess, like, okay. Okay, and returning the references, we have no elision there. So we have to specify, and this will be the internal lifetime of our context. So I believe this should work. It still doesn't. Okay. Because our user is not an GraphQL output type. So here is our structured user, and we could write something like object, like we did, and then we could impl user, and async fn id. And this will compile, but it's really tedious to write everything. So for cases like where we want to expose all the fields from the user struct, we have the macro from async GraphQL, simple object. And this will do exactly what I did, but for all the fields for us.
Can I provide custom resolvers for some of those?
We will get to this. And we want to derive because it will generate additional code, not operate on our struct. So now everything is working. We can see if it compiles. And we should see our user now because it's exposed through this endpoint, which is root. Okay, and now if we query for users, let's say name and surname, everything works. Let's query for maybe also the car ID, so we can then transform it to actual car. No field car ID, because it uses camel case. Okay, so now everything is working. Okay, let's go back here and also create the one for the cars. And also car needs to implement the simple object.
This will fail, right? Because we haven't provided cars yet.
What?
And this will fail as it is right now, right? On the runtime, because we haven't provided cars.
Yes, it will. And also it's complaining that we are using the brand here, which also isn't the GraphQL type. And as this is enum, we have the enum macro. It's more like the C enum, not like the rich some type from Rust ecosystem, like from Rust machinery. More. But those who are in RFC of GraphQL, so we will get them. And async GraphQL already supports them, but it's still not supported by the standard. Okay, so
Sorry, this derived enum is by GraphQL.
yes, it's the GraphQL enum.
Because of the star.
Yeah. Because of the star, we will have some simpler coding for now. Okay, and now this should be working like in our schema definition and so on, and we will get, like you said, the runtime error when we try to fetch our cars. And let's say ID, and let's close the brace. So the data doesn't exist. So we will attach it quickly. And it will work. We will not check this time. And we will go to the defining our custom resolvers for those objects. So I think that's kind of funny, because to do so, we have to now mark this simple object as GraphQL complex. Okay, and this is complex simple object. And then we can write complex object macro and implement this. Like let's say async fn car, and it only it requires self, it requires the context, so we can get actual car. We also operate on references there, so let's specify them ahead. And this will return the maybe car. Okay, and what we need to do here is just grab the cars. Let's grab those we already written, and then let's iterate through them and find the one that we are interested in. Okay, and this returns an option. We can just say convert it to the result. So let's say awk or else, awk or let's say not found. because we can just write the string slice here because it works for any type that implements to string, and we can assign it maybe and return. Okay, so we got the car resolver. It should show up in a moment.
But it does the same like the default one, yeah? Or not?
Which default one?
Without providing the simple user this function or the simple object. Or
But simple object has the field car ID, and it only has the ID of the car we want to return. And now we created the resolver, which provides the car itself.
okay.
So it's like you queried the car from the database, let's say, because normally you would have like connection pool to the database in a context instead of the statically hard typed data. And then you could query the cars, select where car ID is equal to the user's car ID, like so. And we have our car there, so we can say now query users, let's say name and the car, and the car's brand and model. Okay, let's close the schema. So you can see it's working, but we still have this car ID, which it's camel case, sorry. Car ID, which is kind of redundant, as we can also query the ID here, and those should be equal, like that's what we fetched. So we can probably remove this car ID, and how you do this is just say that to GraphQL to skip this field. And it will compile. Okay, we can now try to query, but car ID is no longer existent in our object. So we have now like the whole structure just as we wanted. So we have no car ID, but the car itself, and we can create autoreferences and query all the data we want in one query. Let's do the same for the car, because car has the owner ID. So we have to write that that's complex. Not this way. Let's copy this. It will be faster. And we also skip the owner here. And this should give us the same thing on our cars. So we can now create graphs. Okay. You can see that car here now only has the owner, doesn't have the owner ID. And if we query for the owner there, we can check the name that it matches the parent. Okay, so we got JSON who drives Panda. Okay, so in the example from before, you have seen that we had some documentation already backed up to our schema. So it's as easy as writing the usual RASDoc comments. So we can say that this cars ID, and let's say cars brand. We won't document everything, just to show. We can also document those functions, like get the owner. And this will compile pretty fast, as this doesn't have anything to compile. No, maybe it does. So we have the documentation for our fields or resolvers. We can also document arguments. Oh, but I didn't read I haven't written the limit argument here, so we can do this right now. So as this is macro, we can provide there after the context, which has to come second if we have something other than itself. We can then specify any amount of arguments that our resolver will take. So let's take the limit of use size and let's use it. So let limit goes to std compare min, so we don't overflow because it will still panic limit and users len. And we then have to slice our users. Okay, we should now be able to specify the limit there, like limit to. Oh, have it worked? Yes.
And limit 3 produces error, right?
No, I hope that there is no error there, but let's check the 3. And let's overflow. We have 5 users. You can trust me or not, but let's write. Oh, not there. But let's write like 100, and we'll stare. It will be the. I hope it will. I haven't checked that, to be honest, but it says that it's an invalid number. Sorry. Like we can check what is the type of the int, but it's invisible a bit. Oh, I can read it. It's the scalar type represents non-fractional signed whole numeric values, so it's signed. It's U32, but as our resolver uses Rust and usize, it seems that the error may be from Rust, not from the GraphQL itself. But I'm not sure about this. This is the first time I tried something like this. But the positive 100 should still work and return less than 100 users, so we are bounded still by the size of our users struct, like vector. Okay, and we can also pass some documentation to our fields, and also something more, like here is where we can specify the default value, so we can say GraphQL. Let's keep the limit actually. We can say that description is the maximum amount of users queried. And we can also say that default is 15, but before we compile this, let's see that if we don't provide the limit, as this doesn't have the default, yeah, it crashes required but not provided. So now we can save this. And now it works with the default value of 15. And also, believe me or not, because you cannot see this, but the limit argument now has some documentation, and here is our description provided. Okay, so I guess this is all about simple queries. We will now write the second root object, which is mutation. And the difference between query and mutation is that there is no difference. Like, you can write mutations which are just simple queries and don't modify any data, and you can write queries which modify data, because those are all just async functions, and there is no way to check that you are not violating the rules. So this is pretty much the gentleman's agreement, that the query is for querying and mutation for mutating, but there are no guarantees. So let's write some type mutation. And from the example that I showed you, we had some mutation. Let's put it below the query. So macros, procedural macros like live in some different namespace, so we can name those two equally, but this one is macro because it's used as macro. So we are free to go with naming our mutation just a mutation to keep things simple. And we had some example of call for help where we take the mutation, take the context. I think we don't need the lifetime there. Okay, and the user ID will be the ID of an user who wants help. We can now return anything, but we have to return something. So we can't return null there or none, I don't know. We will just return the user that called for help and let it be user to not write the context lifetimes. This will require us to clone, so do this ahead. Okay, jumped a bit too much. And pretty much the same thing that we did there. So let's take users. And the user we are looking for will be users, iter. Oh, it's more like from the car example and the owner. Find the user. And then let's for now just return this user because we have no subscription yet, so we have nothing to pass the data to. Something is wrong. Ah, okay. Yeah, that's correct. Yep. Okay. Cannot find attribute mutation in this scope. Mutation is scope, but it is a struct, not an attribute.
You define the struct with the same name as?
No, I believe this comes from here because we specified our schema as using mutation, but in builder there is still empty mutation. So now it should be fine. It's still not fine. Because there, no. Sorry, this is just the regular object macro, like from the query. Only the subscription has the different one. Okay, saving. Yeah. I told that and then I written the mutation. So it's just the regular object macro, and now we should have this in our schema after it compiles. Oh, yeah, it compiled, so there is call for help. So let's assign name to this query so we can differentiate between different ones. And it will be its mutation. For help, and the user ID is, let's say, 1. And as we are returning the complex type from this, we also have to select the fields. Let's select only the name. Okay, so after calling it, we got our user with ID 1. And let's write the subscription. So let's read the empty subscription and like, okay. And subscriptions are kind of different because they operate on WebSockets. So there is separated macro. This time it will work. It's subscription. We can implement this and like async fn listen to help calls or something like this, which will take self, and I think nothing more will be needed. So we want to return our user, but as this is subscription, we will return the stream type, which is like async equivalent of iterator, just acquiring next value is an async call, so we need to await this. And the stream, where item type will be user. And we unfortunately are not allowed to use references there. I don't know why, I haven't digged so much. So let's have something like this. I don't know if result will be needed, probably yes. And as for now, we don't have the machinery to pass their users. We will use channel for this in a moment, but for this time, let's make this just compile for a moment, so we will return like just ints to see if our subscription is working, and we can create like dummy stream, because this stream doesn't have to await anything, so it will be stream iter, and let's iter something, so like 1 to 5. I hope this works. Okay. Futures stream. Okay. Seems that it tries to compile. It does. Oh, it does it again. I don't know why. Maybe I've hit the save again. Okay, and we have now subscription also in our queries, so we can try to use it. Let's name it foo to make things faster. Listen to help calls, and it returns the scalar, so we don't need to select anything, and it immediately returned us our iterator because the values were already there, like we haven't had to wait for them. And as soon as this stream has finished, our subscription is finished. When we have like pending subscriptions, the play button will be something like stop button. We'll see that in a moment. Okay, so we want to somehow pass the user from there to here, and let's use some channel for this. Actually, channel is good when you have one listener, so we can have multiple listeners, so we can use Tokyo Broadcast. Sorry. Okay. And we will also have those as a fields, like the sender, like users tx is a broadcast sender of user. Okay, and the same goes for our subscription. In subscription, we also have the sender, not the receiver, because broadcasts work in a way that when you want to have the receiver, you just subscribe for the sender. So that's why we have the sender there. And also let's initialize this broadcast. As we need only sender, let's just grab the TX. It's pretty similar to the MPSC channel, like broadcast, channel, and the capacity, which is for like lagging. If some subscriber skips some messages, he can retrieve them, but not in our case, we don't need this. And let's pass it to our objects. So this one we have to clone to pass it also there. Should be fine now. Okay. And let's now publish it there, like self users tx, and it's send user clone. And can this fail? I don't remember. Yes, it can, so we can return in case of error, and here we can grab the users that are provided for us, but unfortunately let's grab the listener, so it will be self users tx subscribe. Can this fail? No, it can't. Okay, and the RX have the like RX res3 await, which will provide us with the result, but it's not a stream yet. And to create the stream of this, we can use some Tokyo wrappers because it's not in Tokyo standard, or we can use fine async stream crate, which provides us with the stream macro, which looks a bit like Python.
Just Rx does not already implement stream?
No, and I don't remember the reasoning for this, but the stream is not like the type in Tokyo. Like, I think they were wanting it to be the STD, but the Tokyo's 1.0 version was released before the STD's one, so it was kind of the... I've read something about this, but not really remember. Okay, so this isn't the stream, but we can now do the stream macro, and we can we can call yield, like yield1 will create a stream with one element of 1, and we will want to say while let okay user equals rx resv and await this yield user. Something like this should work. And we have the type mismatch there. And it should be fine, but it's not mutable. Okay, it seems to be working. So now we have user there, and we should be able to call for help. Let's open the second tab so we can see this side by side. Let's close the schema. Maybe make this a bit more equal. Not ideally, but let's say. And here we will subscribe. Okay, so now we have complex type, so we need to select subfields. Let's select the name. Okay, we are now listening. This error will stay there, but worry not. And we can call for help for user with ID 1. Okay, it's complaining that this query is also wrong. I don't know why, because we are not executing it. And I haven't changed the focus, so I hope I haven't modified anything there. Let's say also the name, and it now allows us to execute this. Unfortunately, the scrolling is not yet there. Let's say user with ID 3, and okay, this sucks that we cannot see this one by one. I can focus. So I switched to manual focus management to, that is all, so it doesn't work. But I don't know what's wrong.
You didn't execute this way, right?
Okay. Okay, so now we have more data. And we can do so as long as we want. Okay, so I guess that's the full example from what I showed you before. So we have this query, mutation, subscription. We specify our data as almost plain Rust objects. Everything like documentation works. So I guess it's a bit simpler than writing the roots and the REST APIs. Like REST APIs probably give you a bit more control because here you have the machinery executing your queries, but it has just the fast time to market and is quite easy to write. So when you want something simple, you can take it. We've also scratched only the surface of it, so there are a lot of more things to explore for future if you would like to. Any questions? Yes?
I have a question how this subscription receives additional data. You roll side by side to window, right?
Yes, so it received the data because it connected as a WebSocket. So it opened the WebSocket connection with our server and said that it listens for the data. And then every time our server receives new data to the stream, like where it was.
What triggers this event of receiving?
Could you say that again?
What triggers receival of this event?
Yeah, so here we are returning the stream, and we've built the stream out of the receiver of our transmitter receiver pair, and we were triggering it by sending the user from this endpoint. So every time we got the new data, we were actually calling the call for help.
Okay.
It doesn't work now. It says channel closed. It can't transmit the data as it has no listeners. But if we open a new type and subscribe, listen to help calls, name, and start this, it should now work. Like we trigger the new data here by calling this mutation.
Okay.
Any more? Okay, so I think we are done for today. Thank you very much.
Thanks.
The thing is, we have 2 T-shirts to give, and we don't know exactly how to dispose them, or how to, So,
You can cut them.
no. The thing is, both presenters will ask you now 1 question each, and the one that will be first to respond will get a T-shirt.
What is the difference between Rust and Ruby?
No, it is not you that will ask the question.
But
So-
there is not much difference actually, so you know.
So come on, ask.
Questions or regarding the talk?
Yeah, regarding the talk. Come on, come here and ask the question.
Okay. I have nothing prepared, but maybe let's say, what is the only required type when you create GraphQL schema? Yes.
Congrats. Who was this?
Okay, so from my presentation, of all the lints I mentioned, there were 2 lints which were not like for Rust itself, but for crates outside of the ecosystem. What were the 2 crates? Oh gosh, who was?
Yeah.
I think Maciek is a presenter, so and you 2 were first, I guess.
I can wear it Monday, you in Tuesday.
You can wear a T-shirt one day and you can another day,
Yeah, actually.
Or maybe.
So,
Do you want me to ask
the
a
thing
different
is
question?
And maybe different question, just tiebreaker.
yeah.
Oh, tiebreaker. All right.
So everybody who answered the previous one
Yeah.
will have a chance to answer the next one. And by the way, you will get your T-shirt because you are a speaker. So.
I didn't
Oh.
know that, so I tried.
Yeah, understandable. So grab one, so you don't need to reply.
Okay. What?
Favorite color?
What was the total number of all the lints in Clippy? What?
348.
Yes, 348, exactly.
Come on, that was impossible to respond.
I admire your memory actually.
Yeah, I'm impressed too.
Okay, so I think this is all for today regarding the agenda. We will have, some integration somewhere nearby in the pub or something. I think we can discuss which one we will choose today. So, yeah. Thank you all online. Bye-bye. And welcome after party.